Hello, welcome to another module in this massive open online course on probability and random variables for wireless communications. So today let us start looking at a new topic, that is conditional probability. So today we will start our discussion on conditional probability. So conditional probability, consider two events A, B. Now the conditional probability of A given B is defined as the probability of, is denoted by the probability of A given B, which is the probability of A intersection B divided by the probability of B. So we are now defining a new concept, that is the conditional probability. Let us say A and B are two events. The conditional probability of A given B, that is how is the probability of A, or how is the probability of occurrence of A affected given that the event B has occurred. That is, let us say someone has told you that the event B has occurred, then how does that affect the probability of occurrence of A? This is termed as the conditional probability, that is denoted by the probability of A conditioned on the event B, which is equal to the probability of A intersection B divided by the probability of B. And therefore naturally this also implies that the probability of A given B times the probability of B equals probability of A intersection B, or in other words the probability of A intersection B is equal to the probability of A given B times the probability of B. And also therefore we can also write this as, so we said we have probability of A intersection B equals probability of A given B times the probability of B. Similarly we can write we can define the probability of B conditioned on A as the probability of B intersection A divided by the probability of A, which basically implies that the probability of B given A times probability of A equals probability of B intersection A. And now you can see probability of A intersection B is probability of A given B times probability of B. Probability of B given A, probability of B intersection A, which is the same as probability of A intersection B, is equal to the probability of B given A times the probability of A. Therefore from these two we can conclude that the probability of A given B times the probability of B equals probability of B given A times the probability of A, and both are equal to the probability of A intersection B, which basically implies that probability of A given B is equal to the probability of B intersection A times the probability of A divided by the probability of B. So, the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B, alright. So, we derived important property of the conditional probability. This is also known as the Bayes result. We will explore more about this later. So, first we have said that the probability of A conditioned on B is equal to probability of A intersection B divided by the probability of B. Similarly, the probability of B conditioned on A equals the probability of B intersection A divided by the probability of A. Let us now look at an application of this concept of conditional probability in the context of our Mary-PAM modulation. Remember, our Mary-PAM stands for pulse amplitude modulation. So, let us look at a simple application of conditional probability. So, let us look at a simple example of conditional probability in the context of Mary-PAM. Remember, we are considering Mary-PAM for m equal to 4 symbols, and PAM, remember PAM denotes pulse amplitude modulation, which is also basically amplitude shift keying. And remember, for m equal to 4 symbols, our sample space S consists of the symbols -3 alpha, -alpha, alpha, comma 3 alpha. We are considering 4 PAM, that is Mary-PAM pulse amplitude modulation, which is a digital modulation, that is, this is a digital constellation from which the digital transmission symbols are drawn. Further, we are considering m is equal to 4 symbols, that is, we are considering m equal to 4 symbols, and the sample space for this is -3 alpha, alpha, -alpha, alpha, comma 3 alpha. And we also consider an example in which the various probabilities are given as 1 by 8, 1 by 8, 1 by 4 and half. And let us take A as before, let us take A to denote the set of symbols -3 alpha, comma alpha, and B to denote the symbol alpha. Now, what we are asking is what is the conditional probability of B given A? What is the conditional probability of B given A? So, we are saying A, the set A denotes the PAM symbols -3 alpha and alpha, B denotes the PAM symbol alpha. Now, we are asking what is the conditional probability of B given A, that is, given that event A has occurred, that is, the observed symbol belongs to the set -3 alpha, comma alpha, which means to say that is the PAM symbol is either -3 alpha or alpha. What is the probability of event B conditioned on A? Given A, what is the probability of B? That is, what is the probability that the PAM symbol is alpha? Remember, B is the PAM symbol alpha, right. So, we are asking what is the probability that the observed symbol is alpha, given the observed symbol is either -3 alpha or alpha. And this can be found as follows. We have, that is, what is probability of B given A? Probability of B given A equals probability, this is equal to the probability symbol equals alpha given A, that is, symbol equals -3 alpha or alpha. And what is the probability of B given A? Remember, from the definition, this is equal to the probability of B intersection A divided by the probability of A, and probability of A equals, remember, probability of minus 3 alpha comma alpha, which is equal to the probability of minus 3 alpha is 1 by 8 plus the probability of alpha equals 1 by 4, this is simply equal to 3 by 8. Now, what is B intersection A? B intersection A is basically minus 3 alpha comma alpha intersection alpha, which is B, and this is basically the set alpha. Therefore, we have probability B intersection A equals simply the probability of alpha, which is equal to 1 by 4. So, we have found two things. We have found the probability of A, which is 3 by 8, and we have also found the probability of B intersection A, which we are saying is basically 1 by 4. And therefore, the probability of B conditioned on A, therefore, the probability of B conditioned on A is simply the probability of B intersection A divided by the probability of A. This is equal to 1 divided by 4 divided by 3 divided by 8, which is equal to 1 divided by 4 into 8 divided by 3, which is equal to 2 by 3. Therefore, we have derived probability of B conditioned on A equals 2 divided by 2 over 3. Therefore, the conditional probability of B given A, or the probability of the event B conditioned on the event A is 2/3, that is 2 over 3. Now, let us find the other conditional probability. What is the conditional probability of A given B? So, now let us find what is, or let us ask the question, what is probability of A, what is the probability of A conditioned on B? That is, remember, A equals minus 3 alpha comma alpha, B equals the symbol alpha, that is, we are asking probability that the symbol equals minus 3 alpha or alpha given B, that is given symbol equals alpha. And therefore, what is the probability of A conditioned on B? We are saying that the A is the set minus 3 alpha comma alpha, B is the set alpha. Therefore, the probability of A conditioned on B is the probability, we are asking the question, what is the probability that the observed symbol is minus 3 alpha or alpha, when it is already given that the symbol observed is B, that is alpha. And clearly this probability should be 1, because given the symbol is alpha, the symbol is alpha. Therefore, the symbol is definitely either minus 3 alpha or alpha. Therefore, the probability of A conditioned on B should be equal to 1, but let us check that. Let us check that. We have probability of A conditioned on B equals probability of A intersection B divided by probability of B. We have already derived probability of A intersection B equals 1 by 4. Observe probability of B equals probability of basically the set alpha, which is equal to 1 by 4, and indeed probability of A given B equals probability of A intersection B divided by the probability of B equals 1 by 4 divided by 1 by 4, which is equal to 1. Therefore, probability of A given B is equal to 1. And also observe something very interesting, probability of A given B is not equal to the probability of B given A. Remember, we derived probability of B given A, probability of B given A given B is 1. So, probability of A given B is not equal to probability of B given A. So, probability of A given B is 1, which is not equal to the probability of B given A, which we basically derived as, which if you can see previously we basically derived probability of B given A as 2/3. So, this is the concept. So, what we have seen in this module is we have seen the concept of conditional probability, that is given two events A comma B, what is the conditional probability of A given B, or in other words, how does observing event B affect the probability of occurrence of event A, that is the conditional probability of A given B. Similarly, we also seen the conditional probability of B given A, and we have seen a simple example to clearly illustrate this concept of conditional probability, and we will look at other aspects in the subsequent modules. Thank you very much.